All right, 11.5, operations with roots. Our focus problems for this section are going to be on page 621, 1 through 3, and 9 and 10. We're going to start here with rules for rewriting radical expressions. And in case you haven't heard it, radicals is just a way to say square roots or cube roots or anything like that, okay, when we're dealing with those. So we're going to go over 3 types of operations with these radicals. The addition of radical expressions. If you have the same number under your radical, so x and x being the same, and 2 different coefficients. All right, so if we treat these radicals kind of like a variable, for all x is greater than 0, remember, because you cannot square root a negative number, we can take and add these coefficients. So it's kind of like adding like terms. When we were dealing with equations and we had 2x plus 4 plus 3x, okay, equals 12, we would add together like terms. So 2x and 3x give us 5x plus 4. Okay, same concept here. We can treat these like terms. So a times the square root of x plus b times the square root of x is just going to be a plus b times the square root of x. You can add out in front. Multiplying. When we are multiplying radicals, we can actually manipulate under the square root. Okay, so we can take this square root of x and the square root of y times each other and multiply underneath the square root. All right, you cannot add underneath the square root. You cannot add within there, but you can multiply, and we're going to find out that you can divide. So this would just simplify to a times b and the square root of x times y. All right, so then moving on to division, in a very similar manner, the square root of x divided by the square root of y can be the square root of x divided by y. Again, for all x who is not less than 0 and all y greater than 0. Okay, you cannot divide by 0, so that's why y cannot equal 0. All right, so let's see this in some examples. Example A, we have 2 square roots of 3 plus 5 square roots of 3. So I have 2 of this thing and 5 of this thing. Together I have 7 square roots of 3. All right, and we use radicals because the square root of 3 is an irrational number that we don't want to write out the entire decimal. We've seen how that decimal is infinite and we don't want to write that out, so we keep it simplified as the square root of 3. So this is 7 square roots of 3. All right, here we have 3 square roots of 5 times 2 square roots of 7. So when we're multiplying, we can rewrite that as 3 times 2 times the square root of 5 times 7. We can manipulate underneath the square root here. 3 times 2 is 6, 5 times 7 is 35, and we now have 6 times the square root of 35. All right, and for some radicals, we can then reduce down within the radical. Let's say we have 6 square roots of 75. All right, underneath that radical, I can say that's 6 square roots of 3 times 25. All right, and then I can rewrite that opposite of what we just did above. That's the square root of 3 times the square root of 25. And since I know the square root of 25, that can be 6 times the square root of 3 times 5. And now I can simplify even further. 5 times 6 gives me 30 square roots of 3. All right, so you can multiply underneath the square root to simplify, or you can simplify and expand underneath a square root to get a more simplified version of your answer. For class, why don't you try this example B with division? Remember, you can take 15 divided by 3 under the radical, and then for a little bit of a challenge, distribute here this square root of 3 into this equation and see what you get there.